Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at the important topic of catching exceptions in the right order. And this is a question that comes up quite a lot on job interviews, but it's also just important to know for the sake of your own coding, of course. So I want to take here two exceptions where one exception is a subclass of the other. So I could define my own custom exception here and create a subclass of it for the purposes of this tutorial. But what I'm going to do is I'm going to use the standard exception as an example of my superclass, parent class, and I'm going to use badalloc here, which is a subclass of the standard exception class, as an example of my subclass. So the important thing is we've got this child-parent relationship between our two exceptions. Now let's create a function here. I'll call it goes wrong, and depending on what goes wrong in this method, it's going to throw one of two exceptions. So we could say, let's say bool error 1 detected, let's set that equal to true, and bool error 2 detected equals false. And let's say here if error 1 detected. So if some kind of error, which we're just calling error 1, is detected when this function runs, it's going to throw a bad alloc like that. And we can say that later on, let's say it doesn't throw that bad alloc, so the first kind of error is not detected. I'm not detecting errors here, I'm just setting a Boolean variable, but imagine that we're detecting these errors somehow in the code. Imagine error 1 is not detected, the code continues, and it throws an exception like this. Let's just include in here, although IOStream is helping us, but let's include the exception header here. I think bad alloc is probably in this exception header. If it isn't, for your compiler you might need to include some other header for bad alloc, which you can easily find just by doing a quick Google, but this works on my compiler and I imagine will work on most. So let's try this. Let's put it in literally try it in a try block. Let's call goes wrong, and I'm going to write some code here. I'm going to say catch exception reference e. This is the parent class, and I'm going to do a cout e.what endler. Then let's put a catch bad alloc reference e, and let's do a cout e.what again, and let's run this code and see what happens. So we can see here that we've got a method that could throw either of these two exceptions depending on what errors occur. Well, in fact it can't because of these booleans, but imagine that potentially it could throw either one of these two depending on exactly what goes wrong. It just so happens that this time it's actually going to throw bad alloc. So let's try running this program and see what happens. Now we get here from e.what we've got bad alloc printed out. So the code appears to work as we expect, but in fact it's not working as you expect it to. You might be able to spot what's wrong here, and the clue is polymorphism. Remember, polymorphism guarantees that we can use a subclass wherever a parent class is expected. So what's going to happen here is goes wrong throws this bad alloc exception, and it works down the catch blocks one after the other. The first catch block that it encounters is this, so it's expecting something of type exception, and remember bad alloc is a subclass of this exception class. Therefore polymorphism tells us that it's going to fit here. This is going to accept bad alloc because bad alloc is a kind of exception in the sense of this class. Therefore it's actually this what that executes, but because the underlying object that's being thrown is of type bad alloc, because what is a virtual method, we get the correct error output. But if we put some text in here to illustrate what's actually happening, catching exception, and let's put down here catching bad alloc. Let's run this. What we find is we're actually catching, when the program actually runs properly, we're actually catching exception. We're not catching bad alloc, you notice. We're actually executing this. So the upshot of this is that you must be careful to catch your exceptions with the subclasses before any of their parent classes. Otherwise, they're useless. And again, we'll get an error or a warning about this in Java. But because C++ it's basically just doing what you tell it, it's limited in what errors it's able to detect at compile time. So C++ lets you write this code, it just doesn't work as you expect. So always put the subclasses first. And now if we run this, we correctly catch bad alloc here, so we're executing this. If we were to throw error 2 instead, we have no problem now, because if we run this, we get catching exception, standard exception, so we're running this. Because bad alloc is a type of exception in the sense of the exception class, but the exception class is not a type of bad alloc. So if we throw exception here, the parent class, it will not fit into this catch block. So it's really important to understand that and to watch out for that. So again, I'd recommend trying that out for yourself. Just give it a go, and then you might one day get a job that you wouldn't otherwise get. Have a go at. It's also good if you feel like going to the trouble of declaring your own exception parent and child classes and experimenting with catching those in different orders. And you'll see again that what happens is you need to catch the subclasses before the parent classes because of polymorphism, and we covered polymorphism in a free beginners course if you want a refresher of that. Okay, so that's it for this tutorial. Until next time, happy coding.